Hello friends, today in this session we will discuss Z test, T test and ChiSquare test in R Studio. So let's start and let's have a glimpse of what is Z test and T test. So Z test is performed in cases where the test statistics is T and the standard deviation sigma is known. The population is normal and the sample size is at least 30. So the formula to calculate Z test is Z statistics is this one. Okay, so we all know this formula. So how to apply this formula? See, firstly I'll create two vectors in my R Studio. Okay, x1 with values 1 to 5 and x2 is from values 2 to 6. So let me run this. X1 and x2, these two vectors I have already created, as we can see in the console. Now the first thing is, to run Z or T test, we need a package called BSDA, that is Basic Statistics and Data Analysis package. This is one of the oldest package and very powerful package. So it must be in your packages. Okay. So let me check whether I've called the package or not. Yes. Okay. So this is the package. So either you can write library or in this way library BSDA, or you can click on this checkbox. If you do not have this package in your R Studio, you can install it. Okay, you can go to install and repository CRAN. Here you can write BSDA. Okay, it will come and you can install. Or either you can write a command install.packages in double quotes, write BSDA. Okay, now once this package is installed, what I'm doing to perform Z test, write z.test. Okay, provide your two sample x1 and x2, x1 x2. Okay, I have provided sigma dot x. Sigma for dot x means for this one, first vector. So sigma is our standard deviation, and I have provided by default I have given 0.5, and for x2 as well I have provided 0.5 with confidence level 95%, 0.95. Okay, so if I run this, now see, this is the answer. This is the output, which we can see two sample Z test, because we have provided two sample x1 and x2, and our alternative hypothesis is true difference in mean is not equals to 0. See, if we see mathematically, mean of x is 3, mean of x1 is 3, and mean of x2 is 4. Okay, but here when we apply Z test or T test, we compare the means, but not mathematically, it is statistically. We want to check whether these two samples are from the same population or not. Okay, so this true hypothesis, this alternative hypothesis, what is it is saying that true difference in means is not equals to 0, means they are not from the same population. If we make a difference of these two means, and uh, so they are the difference is not equal to 0 means difference is something else, so they are not from the same population, and alternative hypothesis is that they are from the same population. So if we check the p-value, probability value, to check any test we go for p-value. Okay, if p-value is less than, we have already discussed p-values, if it is less than 0.05 means 5%, then our alternative hypothesis is accepted. So in this case, our alternative hypothesis is accepted, that they are not from the same population. But the thing is, here standard deviation is not, I have not calculated standard deviation. I have just randomly I have given 0.5 and 0.5. So let's calculate standard deviation for variable 1 and 2, for sample 1 and 2. So how to calculate standard deviation? You have to write SD, standard deviation of x1. So in this way, if you run this command, you will see the output standard deviation in the console. Standard deviation of x1 is 1.58. In the same way, we can do for x2 as well. So what I'm doing now, I am putting this standard deviation, the output, this output 1.58 into variable called SD1. In the same way, for vector 2, I'm putting standard deviation output in SD2. So let me run this SD1 and SD2. Now, again, I will apply jet test. I have given vector x1, x2. Now this time sigma dot x. X means for x1 first, the standard deviation is HD1, which I have already calculated, this one, HD1. And for x2, it is HD2, this variable HD2. And now I'm providing confidence level of 0.95. You can alter the confidence level 99% or 90%. Okay, but in social sciences we use 95%. So now let me run this. I'm running this line of code, and now see, alternative hypothesis is true differences in means is not equal to zero, means they are their difference is not equal to zero, means there is the difference is some, there is some value, so they are not from the same population. But if we see the, this is alternative, but if we check the p value is 31%, 0.31. It is much higher than 5%. It means when p-value is greater than, when p-value is greater than 5%, in that case our alternative hypothesis is rejected and our null hypothesis is accepted. So it means that both these are from the same population, both the samples are from the same population. Now see, mathematically if we see, the difference mean of x1 is 3 and x2 is 4. Mathematically they are different, but statistically they are same. They are from the same population. The data point they represent from the same population. So in this case we'll accept our null hypothesis. Okay. Now t-test. If you go for t-test, t-test is performed in cases where the test statistic is t, the standard deviation is unknown for the population, and sample standard deviation is known. Now see, here we can go through this chart. So we apply z-test when population is known and we are comparing sample versus population, and t-test, the population is unknown, sample is known, and we are comparing sample versus sample. In that case we apply t-test. So for t-test, again we have to write t.test. I have provided, I'm using the same vectors x1 and x2, sigma dot x 0.5, sigma dot 5 dot y for x2 it is 0.5 and confidence level is 0.95. Okay, so if I run this now, Welch 2 sample t-test. True difference in means is not equal to 0, means it is alternative hypothesis saying that they are not from the same group. But if we check the p-value, it is rejecting our alternative hypothesis, means our null hypothesis is true. Okay, so we can apply t-test in various ways, different ways. How? T.test x1, x2, and mu is 2. Mu is by default it is 0. Okay, now what is this mu? Mu is population mean. Okay, we can see mu is population mean. So now this time I'm providing mu is equals to 2. So if I run this, so now here we can see alternative hypothesis, true difference in means is not equals to 2. Now it is not saying 0 because I have provided mu is equals to 2. And if we check the p-value, it is less than 5%. It is less than 0.05. It is right now it is 0.01. Okay, so true difference in means is not equals to 2. Okay, it means our alternative hypothesis is accepted, is not equals to 2. So this is done when we compare sample to population. Thus, whenever we compare sample to population, we must provide mu, mean value of the population. Now there are different types of t-test: single t-test, two parameter t-test, and paired t-test. Paired t-test is, for example, if someone is in fever and doctor gave a medicine and recording your temperature after 1 hour. Okay, after 1 hour interval, doctor is checking your fever. Next day, he changed the medicine. Now the sample is different. Okay, medicine for the first day it was something else. Another day medicine was different. So doctor wants to check whether which medicine is more effective. Okay, so what we are doing, the temperatures which doctor will observe, they are trying to compare between these temperatures for the medicine, which medicine is better. Okay, to which one is better. This is known as paired t-test. Now, independent sample t-test. There is a medicine and there are two different patients and samples are independent now. So we'll monitor temperature for 24 hours and then we will compare for two different patients. Now sample is, we can understand the sample, the patient is different, patients are different. Okay, and in the first case, in the pair t-test, medicine just a minute. In earlier the medicine was changed but sample was same. Okay, so we check t-test whether both the variables are from the same population or not. So let's take example. I have a marks of some students, and I have given these marks into a vector test underscore data 1. So we have hypothesis or previous learning that average marks of this class has never gone below 70. Thus we test on this new data whether it is above 70, below 70, or what it is. Okay, so I'm going to apply t-test on this test data 1. So if I run this, now see, mean of x is 67. The p-value is 1.522 exponential minus 12. Now what it means, that 1.522 is divided by 10 to the power minus 12, means it is far less than 5%. It is very less. So if this happens, it means our alternative hypothesis is accepted. Okay, so in this, when we applied this test, we do not specify any other factor, only specify the data set. Okay, so in that case it checks against the mean, which is equals to 0. So in this case our alternative, sorry, null hypothesis is true means is equals to 0 and alternative is means is not equal to 0 according to p-value. So h naught is rejected, null hypothesis is rejected. But if we check against the mean or average is 70, now what will happen? Checking, our objective is that we are checking that this class average never goes below 70. So mu is 70. So now if I do this, this is my code t-test test data 1 and mu I am providing 70. And if I run this line, now we can see p-value for alternative hypothesis. Now what is the alternative hypothesis? True mean is not equals to 70 and it is, alternative hypothesis is rejected. Why? Because it is 15% p-value, it is not less than 5%. But Again, it is not solving the purpose because we want to know that true mean is below 70 or greater than 70. So we can do this with the parameter, one parameter, that is alternative we specify. Okay, so how to do that? This is the code. T-test, test data 1, mu I have provided 70, alternative is equals to C, I have provided less. So in this case, our null hypothesis is mean is equals to 70 and alternative hypothesis is mean is less than 70. Okay, null hypothesis is mean is equals to 70, alternative hypothesis is it is less than 70, so we will specify less for alternative. Okay, so this is the line of code, and if I run this, see the output. Alternative hypothesis is true mean is less than 70, but if we check the p-value, p-value is greater than 5%. Now it is 7%. It means our null hypothesis is accepted. What was our null hypothesis? Mean is equals to 70. So mean is equals to 70 for this case as well. Okay. If you want to check greater than, you can put greater over here in the alternative. Now I'm creating another variable. Now this is another variable, and I have saved this as a vector named test underscore data 2. Okay, so what I'm doing over here, now my objective is we have test data 1 and test data 2. So we have two cases over here. Let's suppose test data 1 is the marks of students without training. We have not provided training to the students and we have taken the test. So the test data 1, the marks we have observed. If we have given training to another students and their marks are in test data 2, this will be our independent test. And case 2, if training is given to the same students after uh, training marks are recorded in test data 2, this is paired test. Okay, so I'm taking in this right now I'm taking case 2 when we have taken we have taken test of students and we recorded marks, and after that we gave training to those students and again we recorded the marks. So we want to check whether there is training is effective. There is some significant difference between before training and after training to the students. Is there some difference in the statistically, is there is any difference in the marks of students before and after test? Okay, so I'm doing pair test. So t dot test test data 1 I have provided means before training, test data 2 marks of the students after training, and if you want paired test you will write paired is equals to true. Okay, and if I run this, let me run test data 2 as well, and now if I do paired t-test, now see, alternative hypothesis is true difference in means is not equals to 0. Okay, and the true value is 2.70. It means there is a difference. Our alternative hypothesis is accepted. As alternative hypothesis is there is a difference. The means of marks of students before and after training, they are not same, and our alternative hypothesis is accepted. And mean of difference in the output we can see is 9. If we don't give training to the students, the mean goes down to 9, and if we give training, the marks are increasing. So the training is effective. Okay, now the chi-square test. So I have taken example. Let us suppose we have some data about people using public transport from some government website. I have taken this data from some government website. I'm just assuming. regarding how many people use public transportation city wise. Okay, so let us suppose in city I have given in one city th- this count, this number of people they use public transport. Another city, this is the count people use public transport, and so and so. So now I have provided names to the city as well, and I've taken Delhi, Kolkata, Mumbai, and Chennai. So let me run these codes, city names, and let's see city. So if I run the city in the uh, we can see in the console that the output is 215 Delhi. These number of people they use public transport in Kolkata, Mumbai, and Chennai. Okay. Now to get the proportion of it, I have taken city wise. I'm dividing the total count. Okay. So see, the total number of passengers those who use public transport is if we add all these values. This is total number of values. Okay. And city wise, what is the proportion? So what I'll do, city wise, I'll divide with the sum of the city. If I run this, now see, Delhi, 20% people overall from 100 people, 100% people, Kolkata 19%, Mumbai 34%, and Chennai 24%, 25%. Okay, overall 100%. So I have taken the proportion. So now I want to check whether the fluctuations in the proportions are real. The proportion where Delhi is 20%, Kolkata is 19, Mumbai is very high, Mumbai is 35, around 35% or 34%. So whether these proportions are real means are they statistically significant or the variation is because of the randomness. I just want to check that. And let's assume the probability of all is equal. So I'm giving it in the probability. Probability C probability of all is 25%. 25, 25, 25, 25%. Okay. So I'm assuming that probability for all is equal. So now, according to this data, whether these values are statistically significant or variation is due to some randomness. Okay. So I will apply chi-square test over here. So we may really get a situation where proportions are exactly 25%, but we are testing fluctuations are real or just randomness. So we'll use chi-square test to test this. So how to use chi-square test? Chi, chi, square, sq, and that then dot test. Now, on which data I want to apply this test? This city, and I have given p is equals to probability of all of them are equal, and I have provided 0.25, 0.25, 0.25 in the variable probability. So I have given probability over here. Now, if I run this, now see the value. P value is less than 2 point this one means it is very low, and H naught, our null hypothesis is rejected, means proportion of people in each category is not same. What we were saying that our null hypothesis thesis will be proportion of people in each city is 25% is same, means in each city the same count of people they are using public transport, and alternative is in different cities the people those who are using public transport the count is different. So as we can see in Mumbai there are greater number we can see those who are using public transport. So there is uh, you know people in the city proportion of people in the each city is not same. We can take another example as well. I've taken 500 random selected students, and the question were asked to them that why they are doing technical course. Okay, so for male, 120 students they are doing technical course for good salary. Okay, 75 people doing it for good profile, 105 people are doing it for status. So total count is 300 for male. In the same way, if you check female candidates, female students, 70 female students, they are doing it for good salary, 90 are doing for a good profile, and only 40% females, they are doing technical course for status. Okay, so total is 200 for female. So now the total count is 300 plus 200, that is 500. Okay, so now we have to give our conclusion for this test with 90% confidence interval. So students, I have taken, I have used this function rbind. So what this will do? It takes a sequence of vectors, matrix or data frame arguments and combine them by columns or rows respectively. So rbind means row bind. So see, I have shown you like this in this tabular format. So I want data in this tabular format. So it will be the rows and columns will be combined with the help of this function rbind, row bind. So I have given in the first row 120, 75 and 105. So within the function rbind I have given 120, 75 and 105. For females I have given 70, 90 and 40. So I have in the another row I have given 70, 90 and 40. So now if I run this, so my data rbind data is stored in students, and now I am providing uh, dimension names as well. Okay, so dimension names are, firstly I have provided list for gender. Now see, gender male, then female. Okay, so I'm using list data structure right now. Gender male, female, and reason. What is the reason? Reasons are good salary, good profile, or status. This one, good salary, good profile, and status. Okay, so if I run this and now check what student holds. Now see in the output, reasons are good salary, good profile and status, and genders are male and female, and now my data came in this format. Okay, this I have done this with the help of rbind and list. So now we'll check whether reason of doing a course, it depends on gender. Okay, reason of technical course, whether it depends on gender. So my null hypothesis is reason of technical course is independent of gender. It is not dependent on gender. And alternative is reason of technical course is not independent of gender. Okay, so let's understand carefully the null and alternative hypothesis. The first one is reason of technical course is independent, not dependent on gender. And alternative is it is dependent on gender. So let's check. So if we check, how to check? ChiSquare dot test and student, and if I run this, now see, p value is 4.45 divided by 10 to the power 6. It means p value is of alternative is accepted. Alternative hypothesis is accepted. Means yes, there is a difference gender wise. That see, uh, according to this data, there is a difference gender wise that females, they are not going for status. If more specifically, they are going for good salary and good profile. So and male, they are going for status as well. According to this data, this is hypothetical data I have created. Okay, but the output what chi-square test is telling us that uh, reason of technical course, it depends on gender. It depends on gender wise. So in this video we have learned how to apply z test, t test, and